This lecture is going to go over limiting reactants, the things that you're going to need for this lecture and for the practice problems. You're going to want to have a periodic table, specifically one that you can read your average atomic masses pretty well from, because you are going to have to determine the molar mass. You want to have your objective sheet, and you also want to have your calculator. This is a section that's going to require some math of you. So what is a limiting reactant? It's the reactant in an equation that will limit how much of a product can be formed. So remember, your reactants are on the left side of your arrow. It's what you're starting with. So one of your reactants is going to limit how much of product you can make. And we'll kind of do some math to show you how that works. Now, another thing is you may see the word reagent used instead of reactant. It's the same thing. So you might see a question asking you to determine the limiting reagent. That is the same thing as reactant. So don't get caught up in the terminology. Just know that those two things can be used interchangeably. All right, so a non-chemistry example to get us started. Let's say we have a reaction, and it's 4 tires plus 2 headlights is going to give us what product? A car. So to make one car, I need 4 tires, and I also need 2 headlights. Now, let's say you are given the following. You are given 20 tires, and you are given 12 headlights. We need to determine the limiting reactant in our problem. Remember, our reactants are the tires and the headlights. So with 20 tires, how many cars can I make? Well, that's going to give me 5 cars, right? Because if I have 4 tires per car, 12 headlights is going to give me 6 cars. So what's going to happen here is one of these limits how much product I can make. It's going to be the tires. So this is what we're going to call our limiting reactant. If someone gives me all of these tires and gives me all of these headlights, it's the tires that are going to limit how many cars I can make. But then we have another term that we can use to talk about the headlights, and they are going to be my excess reactant. Because now I have extra headlights. When I make those 5 cars, I'm going to be left with some headlights that aren't being used. So my tires are my limiting, and my headlights are my excess. Those are going to be 2 terms that you're going to become very familiar with. And not just familiar with them, I want you to understand how they are used. So make sure you kind of get this understanding of this example before you move on. So here's our chemistry example now. We have solid sodium and iron 3 oxide reacting. If I have 100 grams of sodium and 100 grams of iron 3 oxide, we need to determine the following things. These are typically the things that you will be asked to find. The first is determine the limiting reactant. The second is determining the excess reactant. Those are the 2 things that we just did with the car. The mass of solid iron produced. So now we know that iron is going to be something that we're going to be producing. That's going to be one of our products. So that's just like determining how many cars we produced. We made 5 cars. Now we're just determining how much iron we can make. And then the last thing is the mass of unused excess. So that was the amount of headlights that we had left. We had 2 headlights left after we made our 5 cars. So go ahead, pause this so you can get all of this written down and come back. Before you pause, I want you to make sure that you write out a balanced equation for this. So you have your two reactants here. Go ahead, write out your products, and then give me a balanced equation. All right, so up here is your balanced equation. 6 sodiums plus 1 iron 3 oxide will give us 3 sodium oxides plus solid iron. So our first step and our second step, so these are the first two things that we needed to determine. We need to find the limiting reactant and the excess reactant by comparing them. So this is just doing that basic stoichiometry that you've done before, where you're comparing one mass to the next. So let's say we start out with 100 grams of sodium. You're going to ask, could we start out with the 100 grams of iron or the iron 3 oxide? Yes, you can start out with either one. I'm going to show you what it's going to look like because you can gather the same information from both. So just for right now, we're going to start out with the iron or the sodium. And we're going to try and go from grams of sodium to grams of the iron 3 oxide. We're going to compare these two. So 100 grams. So now we want to go to moles of sodium. So 1 mole of Na using your molar mass, 23 grams of Na. Now we're in moles of sodium. Now we have to use that mole ratio. 6 moles of Na. Using that up here, this ratio. 1 mole of Fe2O3. Now we are in moles of iron 3 oxide, so now we have to determine our molar mass. I'm just going to do that for you right now. 1 mole of Fe2O3 is 159.6 grams. Of Fe2O3. Now, I told you a few lectures ago, make sure that you're writing out your units. So, same thing as with just the basic stoichiometry. We have moles of sodium, cancel moles of sodium. Now we have, we should start out with grams of sodium, grams of sodium. Those are canceled. Now our unit is moles of iron 3 oxide, so we have moles of iron 3 oxide, and we are left with grams of iron 3 oxide. That's not crossed out, that's highlighted, okay? So now we go ahead and do our math with this. I want you to pause this, come back to make sure that you're getting the same math as me. All right, so what you should have was 115.7 grams of Fe2O3. Now, what does this information mean? What does this tell us? This means that in order for all 100 grams of my sodium to react, I need 115 grams of iron 3 oxide. So one thing that you can do when you are done doing this first step of math is write that 115 grams is needed. Okay? It's going to help you sort what math came from what. So that means I need 115.7 grams. Well, if you go back to the problem, how many grams do I have? I only have 100. So if I need more than I have, let's write that down. If your need is greater than what you have, that is your limiting reactant. So this is one way of us doing this. Now, let's say we would have started with the 100 grams of iron. Let's do the same thing. So we're going from grams of the iron 3 oxide, and we're going to go to grams of sodium. So that was 159.6 grams. Use that molar ratio, 1 to 6. And then 1 mole of sodium, 23 grams. Now, you could have done it this way. You could have started with the 100 grams of iron. You could have done it with the 100 grams of sodium like we did in the first part. So let's just make sure that our units are canceling here. Grams of iron, 3 moles, moles of sodium, We're left with grams of sodium. All right, so going through and doing the math here, I get 86.4 grams of sodium, and this is how many grams of sodium I need. So I need 86.4 grams of sodium to react with all 100 grams of the iron 3 oxide. Now, if what you need is less than what you have, then you're looking at your excess. So sodium is our excess reagent. Now, if you go back to this, the problem we just did, we said the iron was our limiting because we needed more than what we had. So this is our limiting, which means that by default, the sodium here would have been our excess. So you don't have to go through both steps. I'm just showing you that it doesn't matter which one you start with, you can get the same information from each. So I could have started with this and found my limiting, or I could have started here and found my excess. And then just by default, the other one is the opposite of whatever you found. Okay, so now you have answers to number 1, and you have the answer to number 2. Now, number 3 was we wanted to determine the mass of the product, which product it said the iron. So we want the mass of the iron produced. What you have to remember in this, and this is key, is you must go by the limiting reactant. So highlight this, underline it, star it, whatever you need to do here. Your limiting reactant determines how much product you make. Just going back to the cars, we can't go by the 12 headlights we had. We had to go by the limiting, which was the tires. The tires limited how many cars we could make. And in this situation, this iron 3 oxide is going to limit how much iron we can make. So what we have to start with is our 100 grams of the iron 3 oxide. So we're going from grams of the iron 3 oxide to grams of the solid iron. Now it's just that basic stoichiometry that we already know. So using that molar mass again, now we're in moles. Now your molar relationship is 1 to 2 here. moles of iron. And now we just need our molar mass of the iron. 1 mole of Fe is 55.8 grams. Double check, make sure your units cancel out. Grams of iron 3 oxide, grams of iron 3 oxide, moles of iron 3 oxide, moles of iron 3 oxide, moles of iron, grams of iron. So go ahead, go through, do your math on that. Pause it and come back. $69.9 grams of solid iron. So that is your answer to number 3. Remember, we started with our limiting because it limits and determines how much product we have. All right, question number 4, determine the amount of excess that is left. Now, if you remember the second problem that we did, let me slide back here, we found out how much of the sodium was going to be used when we used all 100 grams. So we said that in order for us to use all 100 grams of the iron 3 oxide, we would use 86.4 grams of sodium. So we used 86.4 grams of sodium. Now to find out how much is left, we have to know how much we started with. Well, we started with 100 grams. So to find out how much is left, we take what you started with you subtract what you used, and that is going to give you your amount left. So 100 minus 86.4 is 14.6. So even after all 100 grams of my iron 3 oxide gets used, I'm still going to have some of that sodium left because it is in excess. Now, as you are doing these problems, step 1 is always to determine what is limiting. What is limiting my problem? What do I have? What do I not have enough of? So it really helps if you write out things like, this is how much I need. This is how much I need. And then comparing. Do I need more than what I have? Or do I have more than what I need? Just compare those and it'll really help you solve some of these problems. And then just make sure that you're using your units correctly, making sure your units cancel when doing those stoichiometry relationships.